In this example, we have multiple parts to practice several things about profit, revenue, and cost. And we're also introducing the idea of a demand function, which can be a little bit confusing. So the first part, we're given the situation where we have fixed costs of $9,500 and variable costs of $175 per item. So the question is, what is our cost function? And so fixed costs, that would be when our Q equals 0. We talked about that in the past. And the fact that our variable cost is $1.75 per item, no matter what Q is, means that cost is a line where we have, if you want to write it, 175Q plus 9,500. Right? If we have, and you can think about it, right? If we don't make any items, we still have a cost of 9,500. If we make one item, our cost is added by 175. 2 items, 2 times that, and so on. So that's our answer for part A. Now, in part B, we're given a lot of information. And we are told that we have 10,500 items when the price is $280, and we have 13,000 items when price is $250. And so we are asked to find the demand function. So we want a demand function, P in terms of Q, price in terms of Q, which may be backwards from the way we think of it. And actually, in some questions, we're actually asked to find Q in terms of P. Right? You put in the price, and it gives out how many you'll sell, which a lot of times might make logically more sense. But for the calculus that we want to do for the rest of the problem, the demand function, price in terms of Q, actually makes more sense. So in this case, we put in the quantity we want to sell or are selling or have to sell, and what we get out is the price we're going to demand in order to sell that much. So think about that phrasing. We'll put in the Q to get out the price, and that can help figure this out. We're told that this is linear, which means we want to come up with an equation of a line. We're given 2 pieces of information, so we're given 2 points. And the problem with this is a lot of students get which one is the X and which one is the Y wrong. So we have to be careful. We want to put in the Q to get out the price. So no matter how the information is phrased, it might be phrased in opposite order, we put in the Q, we have 2 points, Q and price are going to be the points on the line. So in this case, we have 2 points. We have 10,500 when price is 280, and we have 13,000 when price is 250. And we use these 2 points to make a line, which we practiced before. We're not going to show this work in this video. So feel free to pause it for a little bit and see if you can get the same answer as what we get for our demand function. Our demand function when we do the algebra, figure out the slope with change in y over change in x and all that fun stuff, we get -3 over 250q plus 406. The next several parts of this problem, now we're going to use all of this information and put this together. And in part C, we're asked to find the profit function. And in this case, we have to remember that profit is revenue minus cost. And I'm just being lazy and not putting the Q's in there. Well, and there's another layer to this. We need to remember that revenue is price by number sold. Remembering this can help us figure out what this is going to be. We just figured out what our price is going to be using the demand function. So this ends up being P of Q times Q. Sometimes you have a fixed price no matter what, $599 no matter what. So $599 times Q. But in our case, the price that we're going to demand is going to depend on how many we want to sell. So we have that demand function. So in this case, we're going to have our profit is going to be our demand function times Q minus our cost function. So what this is this right here. This is our R and this is our C. And when we simplify this, we get negative 3 over 250 Q squared plus 231 Q minus 9,500. So this is our answer for part C. Okay. In part D, we're asked about maximizing profit. Now, there are two ways we can approach this. The first way, which is the way to find maximum revenue, maximum cost, or if we're looking at minimum cost or anything, would be to find critical points. Maybe there's one, maybe there's of our profit. The second one is special to profit, in that the formula that profit equals revenue minus cost, by taking the derivative and setting it equal to 0, we get that the critical points of profit is equivalent to when marginal revenue equals marginal cost, which is handy if you have these separate already, especially on graphs that we talked about. And it might be handier if you've already found those before you've found what profit is. Lots of different reasons why this one might be handier than the other. Either case, you get, I'm not going to show the work, you get a critical point or a possible max of profit when Q equals 9625. So feel free to try both ways and see how you get similar numbers, similar algebra, and assuming you don't make any algebra or arithmetic mistakes, you get 9625 either way. Now, how do we know that this actually gives us a maximum? Well, one thing that's really nice is to realize, if we look at our profit function, this is a parabola opening downward. So where we have a horizontal tangent line is actually a maximum. So we just found the first coordinate of our vertex of this upside down, if you will, parabola of our profit. So going back to the question, what is the production level for when we have maximum profit? Our production level, so we want to produce 9625 items We want to produce 9625 items. That's our Q. And that was the first part. The second part of this question was, what is that maximum profit? And so our maximum profit we have to plug in 9625 into this profit function, and we get $1,102,187.50. The last part of this is, what is the price? That's actually sometimes, that might be one of the second problem. We want to know how many we produce, what price should we sell it at to find out what this maximum profit should be. And there we plug in the price, we plug into our demand function way up here. So we plug in to little p the value 9625 to get $290.50.